Well, I came back to here. Oh well. Anyway, okay. Things are, ladies, gentlemen, thank you. Things are looking pretty good in the land of Con, so keep up the good work there. Today we're kind of taking a little bit of a pause. We've gotten really through all of the derivative rules that we need. We've kind of completed the tool shed, so to speak. So we're going to take today to kind of organize all of that information. So we don't have any notes from yesterday, but we are going to work on our organizer today, and kind of what we're going to do is we're going to get examples of every derivative rule with the chain rule in it, okay, so that you have kind of that at your fingertips. And then you've got some just some general time to do after this, just to kind of incorporate those derivative rules. So I see a good part of you, a good number of you have already put them together. But the idea is, if you grab these foldable sheets in the circled area right here on the screen, we want to lay them out 5, 4, 3. And depending, you'll have different colors, so it's not all the same color sequence. But 5, 4, 3, lay them down on your desk, get them all kind of one space nicely close to the other, and then just start bending down the other ones so you can see a 2 and a 1 and a cover page. So we are doing just like that. And then you should have a cover page, and it should look like that. Oops. For people at home. I know I don't have the camera on right now because I want you to see what I'm doing right here. So it should look like that. Anybody need a little extra direction with the folder? Okay. So we are going to go then, and I can get the stapler going around the room. Obviously, I can't get the stapler going at home. Kind of cool though. And what I've done is I've stapled my summary. What I did is I actually went to the center. So I went to the center of my my foldable, and then I actually bent back the bottom 2 tabs. I bent them back like this so I could stick the stapler through there, and then I just kind of creased them back. And then that way you can get the staples right on the crease, and then it looks kind of like a book. And then you can open it completely. If you just staple it like this, then you can't open it completely. You know what I'm saying? So if you staple it right on the crease like that, then you can open it completely, and you've got a lot of space to write. So the idea is the derivative. Give me a second. Is somebody beeping in? Or are we still good? Are we still good at home? Okay, it looks like we're still good at home. Okay. So if we open up that first page of the derivative book, you'll see rules 1 through 8. Okay, there's no chain rule in these, but we are just going to set up examples, and then you're going to go ahead and differentiate those examples. Like this one would be that, and then simplify it to 2x. Okay, and you have that. You have all the examples written right in your the flip book, and so that way you'll have the definition here. You'll have the definition here, and then you'll have an example that's worked out, and then you'll have something to go back to as a reference. Okay, so here's the first page real quick, and I'll keep that up until most people are on the second page. All right, here's our quotient rule, low d high minus high d low over low squared. And you can simplify that if you want to. You don't have to. You might not have the space to. Okay. So go ahead and start 1 through 4, and then as I see people in the room finishing up 1 through 4, I'll switch over to the next page so you can compare your answers. But once you work through the booklet, then you can just go ahead and start working on your time. And, or the reading. Oh, I'm sorry. Why did I do that? Did I just put one on that table? Sorry about that. Did anyone, everyone got one, right? Okay. The idea is work through with your cod. Short discussion if you need to. Notice I didn't even do things like I didn't even simplify this, right? The only reason we would need to simplify this is if we had a multiple choice question we had to pick an answer from. So don't think too much about this first page, right? Number 2 is just what's the derivative of 3x squared, what's the derivative of 4x. That sort of stuff. We're just presenting it really formally. I am going to pass around the stapler, which means we're all touching a stapler. So if after touching the stapler, you would like to get up and sanitize your hands, that's totally okay with me. I will sanitize the staplers after it's done testing around the room. And if you want us to use the stapler, yeah, I know you all sanitized when you came in, so we should be pretty clean. Are we ready for page 2? We're going to go on to page 2 here. Page 2, you don't need the bottom one, the absolute value of u. It's kind of interesting. It's just u over the absolute value, and there's a chain rule in there, times the du dx. But we don't really differentiate that using the rule. We'll get into what we do with those things a little bit later. So we're going to hit a chain rule in question 6. There's the chain rule. I have 2 examples for question 7. Oops, my bad. Because we always, for question 7, you know, when it's just a linear term, if the derivative is a constant, but sometimes we forget that this is just a linear term, but it's just a 1/3 x. The coefficient is just a fraction. So that's why I gave you 2 examples for number 7. And if I'm moving too fast, let me know. Or if you need to move ahead, don't wait for us. What? Oh, question 7 aren't in the flip book? Oh, I'm sorry. You're right. I added these last minute, thinking, you know, we should probably have something there, just for linear terms that don't have a coefficient of 1. I'm sorry. Yeah, you're right. I didn't write those. So we're having a discussion here in the classroom. People at home. I did not put these examples in number 7. Sorry about that. You'll have to put those in. Good spare here, in some places there's. Oh, okay, so what I've done is, okay, we want to funny things on the inside, so we're gonna go like this. So I just did this, I just over that. So that I can get this over here and get it also in line with that. With that. That makes sense? And then I just folded it back and kind of smoothed it out. So if we staple it like this, you know, so I just moved that. So that are we ready for the next page or? And yeah, like I said, if you're moving faster, keep moving. You can just back check these when you get to the page. So now we're starting on, now this is, if you notice, starting with number 9, we're going to incorporate the chain rule, right? So these examples are going to look like something like that, right? Sine of 4x cubed, not just sine of x, but sine of some complicated function, right? So you take the outside derivative of sine is cosine, then you take the inside derivative of 4x cubed is 12x squared, multiply them together. And typically we would write this as 12x squared cosine 4x cubed, right? We would bring this coefficient out front typically, but I didn't even simplify it. Not necessary really, but it does look a little nicer when you do that. Is everybody stapled who needs to staple? Well, I started one in the front and one in the back. Making the rounds just to see if you have any questions. Okay, we're moving on to the next page. So we're finishing up the trig rules here. Right, so secant, we know the derivative of secant tangent. We're sticking the 4x cubed in each one of those functions. And then we still have to do a chain rule on the end, right? That secant tan is still the outside derivative. And then we still have the 12x squared, that's the inside derivative. Same with 13. And then 14 is like tangent. That would just be the answer, yeah, for number 12. And if I were to write that in a more simple fashion, I would write 12x squared secant 4x cubed. I would bring that 12x squared up. In fact, in each one of those, that's like 12x squared up. That's the way you would typically see it. So for people at home, Connor and I were just discussing that for all of these answers here, and likewise the previous page, these 12x squared really should be written out front. That's the more acceptable way of writing the answer, just to slide those out front. Okay. We're going to go ahead and get us moved on to the next page. Is that okay? Holler at me if it's not. Okay, so these are all the ones that we just learned, right? And these were literally we can see we can get these with implicit differentiation, but it's way too cumbersome. I just like I don't like to memorize a lot of things, but these are the ones I just like to try to keep in my brain somehow. And remember, sine and cosine, excuse me, I said that wrong. Sine and tangent are by far the most popular ones to be asked about. So that you should have all written already. So arc sine is sticking that 4x. Notice I stick the 4x cubed inside, but it's squared, right? So 4x cubed squared is 16x to the 6th, right? 4x cubed times 4x cubed, 16x to the 6th. And then I need my chain rule there. And that you could write that chain rule on top too. We could stick the 12x. This is the chain rule, right? Derivative of the inside. We could put that up in the numerator too, if you want to even condense that some more. I just, oh, and I did that right there. Look at that. Super magic. So if you didn't catch that on the presentation, I slid that right to the top. And so now that I know that, I'm going to put the chain rule on the top for all of them. If you notice. Okay. So I slid that chain rule to the top. Slid that chain rule to the top. So I just put the chain rule on the top for all of these. Let me know if you have questions on those. Just about another minute or so on that one. And then this last page I really want to go through as a class. So I'm just going to give you a few seconds here, see people still writing. So Okay, so this last page, so 21, we don't deal with LOGs. I'll get to that in just a second though. So remember with 21, I think it was 24, I misspoke. 24, we don't deal with LOGs. Remember with 21, e to the whatever is, its derivative is always e to the whatever, okay? So don't overthink that, okay? You see e to a hippo, your derivative is e to a hippo, okay? Don't, and then we have to differentiate the hippo, that becomes the problem, okay? So e to the 4x cubed is just derivative is e to the 4x cubed times the derivative of whatever it is up there in the exponent. And that should go out in front again. Okay, and likewise, we don't deal with 22 a lot. You know, maybe once or twice an AP test. Probably once in a multiple choice question. But I don't want you to overthink this either. You know, this is still exponential. We just don't have an E here. So 7 to the hippo is just 7 to the hippo. Oh, I rewrote the top one. Sorry, I didn't realize that was there. 7 to the hippo is still 7 to the hippo. Okay. And then I have a multiplier, natural log of the base. Okay. We can put that up here as well. We can put natural log of E up here. It's just that natural log of E is just 1. Okay, so we have a natural log multiplier, and then we have our chain rule. So we have our chain rule right there. And then when I rearranged this, I put brackets in with that natural log of 7 just for me visually, that helps. Sometimes they're there, sometimes they're not. Okay, so 23 and this useful to know one are the ones that simplifying pays off. I think that's the best way to say that. So I want to really talk about these two as a class. So 23, we know that the natural log of u is 1 over u. So this is, again, not something to overthink. You see a natural log, you're going to start writing a fraction, 1 over hippo. Okay, whatever's in those brackets, 1 over that, times the derivative of that. Okay? And so when I say it's worth simplifying, we know that this 12x squared is really up on top, right? And so that's why I say this one's worth simplifying, because we've got some numbers we can reduce by, and we've got some powers of x we can cancel out. So this all cancels down to 3 over x. And so maybe some of you can see a connection to this, from this to this, but there is a pattern here, from here to here. Okay, that will save you 2 steps. So if you want to kind of play with that in your head, great. Okay, 24 LOGs, we can just put a little squiggle through that because there are derivatives of LOG is log base 10, right? And there are derivatives of those. We just don't do them in this course. Yeah, I'm sorry. Hopefully it was only like a question. I have no way of taking them out. That's the bummer. Okay, so we don't do that. You don't have to write this though. You're actually going to need this space. Just do a little scribble here. but we're not gonna need this, but I want to talk about this one, okay? So, like, if we had the square root of 4x cubed and wanted to differentiate that, we would write it 4x cubed to the half power, right? Because we don't have, ladies?
I didn't understand when you went for logarithms.
Okay. We don't have a derivative rule for radicals, so we have to put that in the power form. So we have 4x cubed to the half power right here. And so now we can do our power rule on the outside and then our chain rule on the inside. So we bring down the half, we write the stuff in the brackets, that's the inside, give ourselves a new power, and then do our chain rule, derivative of the inside. And I write tiny here because we've got about 4 more steps here. That's why I said don't write this, because you can use space up here then. So I'm going to write this as a single fraction. We know that 12x squared divided by 2, I can rewrite that. Okay. And so I'm going to rewrite that. And then I'm going to put my, instead of the negative half, I'm going to put that down in the denominator. And then I'm going to start simplifying this. Bless you. Okay, so we know that when we simplify it, we get 6x squared on the top. And notice I put it back under a radical here. Questions? Pardon? Well, because I had a half here, and I had my chain rule 12x squared over here, and I just brought that to the front. And then I said, okay, 12 divided by 2 is 6, so it's really 6x squared. This is really a radical. But this is really, we can bring the 4 and an x squared out, right? So we can really do that. Because the 4 comes out as a 2 and the x squared comes out as an x. And the reason why I'm doing that is because what's going to happen with the top, we're going to cancel that out, right? So we're going to end up with this. But I can still do some more canceling. Because x on the top and root x on the bottom, I have a root I can cancel. Because x is just root x times root x. So we end up with, oops, we end up with that. So there's a lot of simplifying here. Okay, but it is worth doing when you have something like this. Because this is obviously, this form is much easier to work with. This 3 times root x is much easier to work with than what we had up here. So that's much easier to work with. Okay? Right here?
Yeah.
So yeah, I was really limited in space, but really 3x over root x is like saying 3 root x times root x over root x. Right? The square root of x times square root of x is just x. Okay? And the only reason I'm writing it like this is because I want to cancel and cancel. I didn't rational. Oh, you could. Oh, I see what you're saying. Could you just do like square root of x over square root of x and cancel the x's? Yeah. Yeah. So you're saying, hey, let's do this. Right?
Yeah.
And this is just an x. And then just I think that was just okay. I know that last one's a lot of steps. I have to rethink how I'm gonna maybe change up my handout. Hopefully you didn't run out of space. Okay, so you've got I think a short note thing you need to take for tomorrow. You've got some con to work on. You could do a quiz retake. You have a good half hour to do any or probably all of those things. All right, good job staying current. Keep up that work. People at home, I'm going to stop the recording, but I will still be in the live stream if you have questions.